All right, in this lesson, we are going to solve 3 by 3 systems using elimination. So remember, 3 by 3 systems mean 3 equations, 3 variables. Okay, and so we've got 4 examples here. And the list of steps are here. But I want to review how to solve a 2 by 2 system using elimination because a lot of these methods translate to our 3 by 3 system. So when you are using elimination, you are going to add your terms together. So you want to make sure your x's are lined up, your y's are lined up, and your constants are lined up. And when you add them together, you need one of the variables to have a 0 pair. Meaning when you add them together, they add to 0. And so they have to have the same coefficient, but opposite signs. And so I'm noticing a 3 here in front of the y. I could create a 0 pair if I had a negative 3 in front of the second y in the second equation. And so I am going to multiply the second equation by 3 to get 6x minus 3y equals 21. So now when I add that to the first equation, which was 4x plus 3y equals 9, the y's will add to 0, meaning they cancel out. And so 6x plus 4x is 10x, 21 plus 9 is 30, and so that means 10x equals 30, and so x equals 3. Once you have x, pick either of your equations. I think this one looks easier. You'll get the same answer either way. And you are going to substitute 3 for x so that you can solve for y. So that gives me 6 minus y equals 7. Subtract 6 from both sides. So negative y equals 1. Technically, that's a negative 1 that you need to divide by. So y equals negative 1. And so our solution is the point 3, negative 1. Okay, and so here's the steps for solving a 3 by 3 systems. You are still trying to eliminate a variable. And so I think it's helpful to number the equations so we kind of have an outline for you. So usually I just number 1, 2, 3. And so equation 1 is x minus 6y minus 2z equals negative 8. Do your 2's with a loop and your z's with the bar. Otherwise, those turn into 22's really fast. And then we have negative x plus 5y plus 3z equals 2 for equation 2. And then we have 3x minus 2y minus 4z equals 18. Okay, so now that we've labeled equations 1, 2, and 3, we are going to pick 2 of the 3 equations to combine and eliminate a variable. Okay, and so if you look at equations 1 and 2, the x's already create a 0 pair. So I'm going to use equations 1 and 2 to eliminate x. So I'm copying those down. Okay, and so usually you have to scale an equation. In this case, we don't. The x's already cancel. And so that leaves me with negative y plus z equals negative 6 when I add the rest of the equations. Okay, and so equation 4 is this 2 variable equation. I'm going to copy it here. Negative y plus z equals negative 6. Okay, and so the next step is to use the third equation that we haven't used yet. So we haven't used equation 3 yet. And we need to use one of the other equations. So I'm going to copy down equation 3. because we haven't used it yet. We've only used equations 1 and 2. And then now we can use either equation 1 or equation 2, but we still have to eliminate the same variable. Notice that is capitalized. We need to eliminate the same variable. And so I'm going to use equation 2 just because the numbers are smaller, and I like that we already have a negative in front of the x. So negative x plus 5y plus 3z equals 2. And so we still have to eliminate the x's. Even if another variable was easier to eliminate, we still have to eliminate the x's. You have to eliminate the same variable. Okay, and so we need to multiply this bottom equation by 3. And so that would give me negative 3x plus 15y plus 9z equals 6. And so now when we add that to equation 3, the x's cancel. And then we have negative 2y plus 15y, which is 13y. Negative 4z plus 9z is 5z. And then 18 plus 6 is 24. Can't really simplify that, so I'm going to copy it down for equation 5. Now at this step right here, you want to check and make sure that you have the same variables. We have y's and z's. If you accidentally eliminated the wrong variable in this second step, you'd find your mistake right here. You need to have the same variable. And so in keeping using elimination, I think I'm going to eliminate the z's just because I don't want to multiply a top equation by 13. So we need to multiply this top equation by a negative 5. Okay, so that gives me a negative or positive 5y minus 5z equals positive 30. And so now when I add the equations together, the z's cancel, leaving me with 18y equals 54. Divide both sides by 18, and we get y equals 3. Okay, and so now that we have y equals 3, we stay here in this 2 by 2 system to get z. I think this top equation looks easier. So negative y, which is 3 now, plus z equals negative 6. Add 3 to both sides, and we get z equals negative 3. Okay, now that we have y and z, we go back to the original system, pick your favorite equation. I still think I like equation 2. And so negative x, which we don't know yet, plus 5y plus 3z equals 2, just copying down that equation. But now we know z is negative 3. Make sure you put it in the right place. And we know y is 3. So now we just number crunch. And so negative x plus 15 minus 9 equals 2. Negative x plus 6 equals 2. Subtract 6 from both sides, we get negative x equals negative 4. Divide both sides by the negative 1, we get x equals positive 4. And so your last step, once you have all 3 variables, is to write them in alphabetical order. So x, y, z. And so x was 4, y is 3, and z is negative 3. Okay, and so a summary of the steps is you pick two of the three equations and you're going to eliminate a variable, whichever one's easiest. Once you eliminate the variable, you're going to have a two-variable equation, and that's going to be your equation 4. You're going to use the third equation that you haven't used yet, as well as one equation from step 1 to eliminate the same variable. You're going to have another two-variable equation to label it equation 5. And then equation 4 and equation 5 create a 2x2 system. You're going to solve that 2x2 system and then go back to the original 3 equations to solve for the third variable. Write your solution as an ordered triple, alphabetical order.